Going live. All right, welcome back. We are Game 3001. That's Game AI in the winter 2020 semester at George Brown. And it's week of 13, part 2 of our broadcast. We're talking about object pooling. And I want to talk about that challenge. Before the break, I asked you guys to build an explosion class. That's what I asked you guys to do. And use an explosion manager so that you would have an object pool that you would be able to create a series of explosions, store them inside of a container as an example, and then what you do is you somehow get the explosion and return it back into the pool by setting it active and so on. And the way I wanted you to make it work was to click anywhere on the screen and make the explosion appear. So it sounds like it can be tough, but actually it's not that tough. Let's just get into it and see how this works. All right, so the first thing we're going to do is we're going to make a class. We're going to make our explosion class, and I'm going to just shut all this down. So I'm going to close all my documents as we get going. I'm going to go and assume that you've started to make your explosion class. So again, into my my .h file, we're going to call this explosion.h. There's my explosion.h. Add that. I'm also going to add in a new item, which is in the CPP side, explosion.cpp. Okay, there's that part. And then I'm going to include the explosion.h. There it is. In explosion.h, we're going to do the same thing for our guard function, if not defined. Explosion, then define it. Okay, and inside there, what I want to do is I want to make an explosion class. So we're going to say class explosion, which is going to inherit from a public display object. Okay, this stuff we've done before, but we have a plan. We have an example of a sprite that we can use from our plain sprite, which is very similar to what we're going to be doing with the explosion. So again, I'm going to go to my Solution Explorer. I'm going to find the plain sprite.h and the plain sprite.cpp. And we're going to use this as a template for the rest of what we're doing. So plain sprite.h has these three things. You can see that I'm copying, and this is a great indicator to you that I should be making a superclass perchance, right? So also I have this build animations and so on. I want to grab all this stuff and put that inside of my explosion.h. So in the private area. Okay, this is where all that goes in. And then in the public area, I want to put in some of the classes that come with display object. So I'm going to go to here and then generate definition by declaration. Actually, that's not what I wanted to do, but let's try that again. I meant generate missing members, which is what I want to do. Okay, so which is going to generate my missing members. Sometimes it puts them in the wrong kind of location, so I don't want them. I don't want this here. I don't know why it separated this out for me. I want this here. That's okay, and I can get rid of, just rejig some of this. Okay, so there it is. There's the public area. There's my private area. As an example, these are lifecycle functions. So display object, lifecycle functions. That's what these are, and I also need my explosion constructor as well as my explosion destructor. There, those two things are, so explosion constructor and destructor, right? And then what I want to do is I want to define those by using generate definitions by declarations inside of my IDE. Cool, so I've done that. It's all ready to go. I want to make my explosion destructor into its default. And then I want to take a look at the plain_sprite.cpp file and see what I can grab from there. I know that I'm going to need a reference to the game.h file, so I'm going to put that inside my CPP, as well as inside of my plain_sprite.cpp. There's a bunch of stuff here. I remember I loaded my sprite sheet and I did all this work. This is all the same. Again, if I copy like this is a great indicator that I should be doing the same thing. I should make a sprite class. But here I can go into my CPP and inside the constructor function, kind of have that go One thing that I did in the constructor function also is initialize the current frame, and I'm going to do that in my constructor function here too. So far so good. It's all the same. The only difference is the size of my my explosion is not going to be 65 by 65. We're going to see how big my explosion text file is. So I'm going to go to my explosion text file here and look at my atlas. Here it is. And you can see that in my explosion text file, I have it go from, let's say, 52 at the widest. There it is, 52 at the widest to 52 height at the tallest. So 52 by 52 is looking like the best size for my explosion. So something like 52 by 52. Okay? That's what I want to do. Okay? And then I'm not going to need the position or the velocity or the acceleration for this one. I'm just going to take those out of my explosion. And my type is not a plane. It's actually, let's go to definition there. Let's make another type, which is going to be the explosion. Okay? And I want to make sure that I set the type to explosion. So we can always look at an explosion object. It's not going to collide, but we can set the collision to false, right? And we're going to call the build animations method from here. So I'm going to go down to build animations, and just like I've done in my plain sprite, I'm going to do the same thing there. So I'm going to grab these lines and go into my explosion and put them in. Now it's not going to be called plain animation, just to keep the right context. Not that it matters, but I'm going to change this to explosion animation. Doesn't really matter. This is just my friendly name. I'm going to call this explosion, right? And this is going to be explosion 1 through 7. All right. Now, how do I know that? Because notice I have explosion 1 through 7 here. Explosion 1 through 7. Okay. So again, I'm just going to copy paste a bunch of times. Oh, God. Copy paste errors. And grab all those frames there and do it again. And I need one more after that. One more. Okay, so again, I could iterate through a for loop of some kind if I wanted to. I'm not going to because I may change this later. So here's explosion. So this makes the explosion animation. It's going to be called explosion, and there's 7 frames of animation here. Okay. So that's what the build animations does. We've already called it from the constructor function right here, right? And then what I want to do is draw the explosion. So how do I do that? Let's go and look at my plain sprite again. So when I draw, I'm just going to call this function, draw. Oops. And I'm going to put that inside the explosion.cpp, inside the draw function. However, I'm not going to draw a plane. I'm going to draw an explosion. Okay, that's what I'm going to draw. That's the animations that I want to pass in. I don't know if this is the speed factor is right now. I'm just going to leave it at 0.5, but my feeling is it's probably going to be okay. And that is the animation that I want to draw. So that is my explosion for the most part. I don't need the plain sprite anymore. However, there are some things that I asked you to do. One thing I asked you to do is I said that I only want to show the 7 frames and then I want it to stop. So it's like I want to do this. I want to say, well, the only time I want to show it is if m_current frame, which starts at 0, right? As long as that's less than the m_p animations explosion animation, right? Dot frames dot size minus 1, if it's less than this, so the number of frames of animation, then it's okay to play it. Right? It's okay to play this animation as long as my frame count is lower than the total number of frames. Else, if it's not lower than the total number of frames, if it's reached the total number of frames, what I want to do is I want to turn off the animation. So what I want to do is I want to set the animation to inactive. I don't have that structure, so let's make it. So I want to have a new structure. So we're going to say that we're going to make a Boolean, m_b is active. Okay, that's the Boolean. I can keep track if it's active or not. And in the CPP and the constructor function, m_p b is active is going to be set to false by default. So it's not active at the beginning. Okay, is active. And so now that I have something I can check for it, I can say that, well, else, if I'm done doing this, I want to set it as inactive. But where would it be set as inactive? Well, I want to set it off screen, and I want to keep setting it off screen over and over again. So what I need then is some kind of reset function. I'm going to call it reset. Again, it can be called other things, but it's going to be called reset. It's going to return void. And this public reset function, which I'm going to define here, right, the reset function is going to do the following. It's going to say, let's set position of my explosion to something off screen. So 1000, like something like -1000, and then -1000. Okay? So that's the first thing I want to do. I want to set my explosion somewhere off screen. Okay? And then I want to set this as inactive. I want to make it inactive, right? But I don't just want to make it inactive, right? For now, I mean, I will do that. I'll say m_ is active, this one. I'm going to set that to false. I'm going to say that, hey, you know, when I reset this thing off screen, it's going to be false. It's not going to be active anymore, all right? So really what I want to do is, as soon as I'm done playing my animation, I want this thing to reset. That's what I want. Okay, and when it's created for the first time, I want this explosion actually to start in the reset position. That's what I want. I want the animation to start reset somewhere off screen by default. Okay, cool. So that's like I'm playing the frames and then I'm not playing them anymore. All right, and it's kind of off screen somewhere. The other one I want to do is I want to know if it's active, and I want to set if it's active or not. Okay, so let's do that. Let's do a getter and setter for those. So again, I'm going to say getters and setters. I want to get is active, so I'm going to return a Boolean. So I can say is active, right? That's my Boolean. And then also set is active. I can set active. How about that? So I can say that void set active, right? So I can only set active. I can't set inactive. I can't make it inactive by myself. I can only set as active. Okay. And why is that? Because what I'd want to do is I want to set it inactive on my own. It's going to deactivate by itself. Okay. Maybe there'll be another use case where I can set active manually, but here I don't need to. All right. So I'm going to go and let's declare all these. Awesome. So is active. Well, that's going to return m underscore is active, the Boolean that we want, right? However, when I set active, I want to say that m underscore b is active is equal to true, right? The only time I'm going to set active is when I need to set active, right? Because I can check to see if it's active and I can return that it's active or not. All right, that's what I'm doing. So a couple of little utility functions to make this thing work properly. Okay, so again, it's only going to draw if my current frame is less than the total animations, and then it's going to reset if it does. By default, it sets as as inactive. The other thing I want to do when I set as active, right? When it's active, I also want to do a couple more things. I also want to set m_p current frame. I want to set that to 0, right? So when I activate it, I want to actually set this to run again so I can show the object drawing again, right? That's what this thing. So this does a couple things when I set active. I can check to see if it's active, right? And then I can set my animation to 0, right? And that's really kind of the gist of what I'm doing here. Okay. So that is my explosion function. That's my explosion class, if you will. Now for the more difficult one, the explosion manager. All right. So for my explosion manager, we're going to do some new tricks. Here's my explosion manager. So I'm going to add a new item, a new header.h. This is the object pool thing we want. Explosion manager. Make sure I spell it right. And then I also want to add in a new item in the CPP, explosion manager.cpp. I'm going to include explosion manager. There we go. And then in my explosion manager.h, I'm going to do my guard, if not defined, explosion manager. Then I'm going to define it. And I'm going to end if defined okay. So that's what that does. What I want is to make a new class we're going to call explosion manager. Okay. And this class is going to be a singleton. So, singleton. You don't have to make it a singleton. I'm just making it one because it makes more sense for me, right? So remember the singleton, how it works. We have two parts, private and public. In the private area, we're gonna define a private static object that is going to return the explosion manager pointer, which is going to be s_p instance. Okay, so that's the actual instance of the object, right? In my public area, I'm going to have a public static that is going to be the instance. It's going to return again an explosion manager pointer. We're going to call it instance, and we're going to say if s_p instance is equal to null pointer, then I want to say that s_p instance is a new explosion manager. That's what we want. And I'm going to return, either way, I'm going to return s_p instance. Let's also return it here. Okay. So what this does is it only makes one instance of my explosion manager. It only does it once, right? Once it has a reference to the instance and doesn't go do it again. One thing to complete this singleton design pattern is actually to put the instance initialization. So again, we're going to say explosion manager pointer. We're going to look at explosion manager s_p instance, right? And that's going to be equal to null pointer. Okay, so that's going to be something we put in the CPP. And again, this is the exact same pattern we've used for texture manager, sound manager, font manager, and so on. Same pattern exactly. Okay, so far so good. We've got our singleton. So we need a couple things for the singleton. One thing that we need is we need somehow, we want to track we want to do this, right? We want to create some kind of structure of explosions. And this is going to be called this is the explosion pool that we're going to need, right? So that's one thing we need, the explosion pool itself. And in order for us to make the explosion pool, we need to think about the proper structure. Sure, I could use a queue. I could use a queue in C++, but the problem with the queue is it's not something I can iterate through. And if I'm going to iterate through like something like a queue, I can make a custom iterator, or I can just use a list, which is kind of a linked list that I can kind of go forward and back in the queue. So that means that here I'm going to make a new structure. So we're going to make a new structure, which is going to be a standard list, so standard template list of type explosion pointers, right? Which we're going to call m_p explosion pool. Okay. Now again, I don't have a couple of these things. One thing I don't have is I don't have a list, and I don't have an explosion. Okay, so those are the two things I need that I need to include from a header perspective. But now I have this explosion pool object. Okay, well, before I do anything, I need somehow. Oh, one thing. I'm sorry, I'm missing a couple things for the singleton design pattern. One thing I'm missing from the singleton is I need that my constructor and destructor are both private. That's definitely something I need, because then it meets the design specifications for my singleton design pattern, right? My destructor could for now be a default destructor, right? My constructor we're going to need, because we're going to call a build. I want to build my explosion pool, so I'm going to make that as a private method. Build explosion pool, right? So remember that the explosions start off in this pool, there's nothing in it. I need to put some stuff in there, right? So that's what I need to do. So I'm going to go here and let's generate the implementation. And I'm going to call build explosion pool from my constructor function. So as soon as I make my pool, I'm going to build the explosion pool right away, okay? And then the way it's going to look is this. I want to explicitly create the pool structure. I don't have to do this in C++, but I'm doing it because in other languages you need to do it, and you should learn what this looks like. So it's like m_p explosion pool is equal to a list of type explosion pointers, okay, and list to be standard list. So it looks like this. This creates an empty pool structure. Okay. And we'll say empty object pool. You don't have to do it because by default C++ will do this for you. However, it's explicitly created this way. Okay. Then I need some kind of for loop. And I need to know how many explosions I'm going to make. So I'm going to make another little thing here. We're going to call it an integer m_explosion number. Okay, and we're going to initialize that inside of the constructor function. So we're going to say that m_explosion number is going to start off at 20. So I'm going to have 20 explosions by default, right? And what I'm going to do is I'm going to use a for I, right? So for I, we're going to call this count m_p explosion pool, this one. So actually explosion number, right? So it's going to say that it's going to count between 0 and the explosion number, so 0 and 20, and then I want to add explosions to the explosion pool. All right, so then I'm going to say m_p explosion pool dot pushback, right, a new explosion. Okay, so it's going to push back these new explosions. Remember that the explosions, when they're created, are reset and set to inactive, right? We know this because in the constructor function we call reset. So they're reset to -1000, -1000, and they're inactive by default. Okay, when I create this, each of the explosions in the explosion pool. All right, so that's the build explosion pool thing. You need this because you need to fill up the pool with explosions. Okay, and then what we need to do is we need to call a function to get the explosion. So again, the way this would work is I'm going to make a public function called getExplosion, which is going to return an explosion pointer. So get explosion. Okay. That's what this function does. It's going to return an explosion pointer. And my get explosion function, I'm just going to generate this thing now. Right? What it's going to do is it's going to do the following. I'm going to go to the I'm going to make a new temporary explosion. So I'm going to say auto, right? And I'm going to get the a new explosion. And that's going to be equal to the p explosion pool dot front. All right, so front, what it does, like we said before, is it looks at the front of the pool and gets a reference to this object, the first object in the front of the pool. Okay? And then I'm going to pop that object off the pool, p explosion pool, and then we're going to say pop, and we're going to pop the front. So we're going to pop the first object off the front. Okay? And I'm going to put this on the back, p explosion pool, and I'm going to push back that same explosion. So I'm going to take that same explosion from the front and put it on the back. Now notice that it says it's recommending const because I'm not really changing it, right? However, remember what's happening here, right? As soon as I push it off the front, I want to set this as active. So explosion, and I want to set active. All right, so I want to set the explosion active as soon as I pull it off of the top. So now it's active again. It's set to 0, it's made active, and so on, and it's going to work. Right? So this is what this does. So this little function, what it does is it does exactly this. It takes it off the top, sets it to active, we copy the front element, and push to the back. And normally, in other languages, we have this ability for us to return. Whenever we pop something from the front, it actually does this copy stuff, right? But here we have to do it manually in C++. Okay? So that's get explosion. We also need a couple of other functions, right? We need some kind of way of updating. We need an update function, and we need a draw function. Okay, I want to be able to update all the explosions, and I want to draw all the explosions. Updating really doesn't do anything right now, but draw will. Right? So what I want to do is inside of this, let's just set those up. So what does update do? Well, I want to say that I want to use the for each this time. And what for each is going to do is p explosion pool. I'm going to create a for each explosion, that's what this is, for each explosion in the explosion pool, if the explosion, right, is active, if it's active, only if it's active, then what I want to do is I want to update it. Explosion update. Okay? And I want to do the same thing for draw. So if I'm drawing, then what I want to say is if it's active, then I want to draw it. Otherwise, don't draw it. Okay? So that's the way I'm doing it. I've got an update function, and I've got a draw function, and those two functions are going to be called externally to this file. Okay, so that for the most part is my explosion manager. Okay, and let's see what kind of fixes it says. Add a return statement. Yeah, that'd be good. If I don't add a return statement, that would not work. So return explosion. I want to return that explosion back out because I want to use that explosion later on. Good, glad that I remember that. Okay, cool. Thank you, resharp or C++. Okay, that would have caused me a world of hurt. Okay, next. So I want to implement this, and the way to do this is inside of my scene. So I'm going to go to my scenes. I'm going to go to my level 1 scene.h and my level 1 scene.cpp. So in my level 1 scene.h, you might think, well, I need to instantiate this stuff, right? No, I don't. It's a singleton. So in my level 1 scene.cpp, that's the only time I need to mention this. I'm going to include my explosion manager.h. Right? And what I want to do is I'm going to listen for when I've clicked the mouse somewhere. So I can use a mouse click. So I can say case SDL underscore mouse down. So sometime when I use the mouse down, and I'm going to use some curly braces here so I can set up a little bit of a scope, right? I'm going to say auto, I want my explosion that I want to generate to equal to, hey, explosion manager, right? I want to get the instance and I want to get explosion. So this actually returns an explosion from the explosion manager, right? And what I want to do is I want to set the explosion itself set position to the m_mouse position. So wherever the mouse position is, so too is the explosion going to go. Okay? This sets it up as active by default. Remember what this does? And wherever the explosion is, so too does the wherever the mouse position is, so too does the explosion is going to be shown. Okay? What I have to do here also is inside of the draw and update function, I have to also draw and update each of the explosions. So I'm going to say, hey, explosion manager, right? Instance. I want to update each of my, actually we do update here, and we do draw here, just to be consistent. Okay, so I want to draw everything in the draw function, update everything in the update function, and that should be it. That should allow me to generate my explosions when I click the mouse button, any mouse button. Okay, let's test it and see if this monster works. And I haven't even tested any of this stuff. So I've kind of created a few things. I've created an explosion. I've created an explosion manager, and I've implemented the explosion manager in my level 1 scene. So my expectations is everything works. When I click somewhere on the screen in level 1, it's going to show me my explosion. It's going to finish doing the explosion animation, and then it's going to disappear. And I can do this over and over again, anywhere on the screen. Okay, if everything is successful. All right, so there's level 1. It's running finally. And if I press 1, I don't have a problem. And if I click this, you can see that anywhere I press, right, my explosion will appear. I can click multiple explosions. Remember, I have up to 20 of them I can make happen at the same time. Maybe if 20 is not enough, I can add more to the pool. But more or less, this only adds one explosion at a time, and the pool remains fixed. It's not gonna increase my memory. My memory is solid. Okay. Questions around this? This is a couple things we covered today. We covered, we covered the idea of the animation system in SDL, how to use that. I asked you to do a challenge in terms of making an explosion. Its own little animation that it kind of shows anywhere on the screen. And I introduced the idea of an object pool, again coming from that design patterns book that we talked about before. Okay, let me push this up to GitHub now. There's been a lot of changes, and actually I'll push it up to GitHub later so you have it. But one thing that I want to talk about now briefly after this is part of your game. Now, one thing that I also included in your game was that Word document, right? So in your game itself, if you notice under courses in your Blackboard, I also included this document to help you with your assignment 3, right? And I talked about this during lecture as well, where you have a bunch of triggers for your actions. So one of the things you're going to be doing for assignment 3 really quickly is you're going to define a bunch of these obstacles, right? So I have an obstacle here, let's say. I have another obstacle here. Maybe there's an obstacle over here, and then there's an obstacle down in here, right? So a couple obstacles, let's say. I'm making random obstacles here. You also have some kind of enemy that is going to be coming inbound, right? The enemy is going to have some kind of health bar, right? This is part of your assignment 3. And you're going to have some kind of player. Let's say the player is down here. We'll make him a diamond shape, kind of diamond shape. There we go. And again, he's also, or the player is also going to have some kind of health bar that's going to show their health. There it is. And what we want to do is, do I have line of sight? Do I have line of sight? If the enemy has line of sight, in this case it does, right? I drew a diagram last time where it didn't. Well, let's say if the enemy has line of sight, or if the player is within the enemy's hearing radius, that's what this is, the radius, right? Then what the enemy will do is come after the player, right? So this is for the close combat enemy. So this is the enemy. And I'm just making this so you guys can visualize what this might look like, okay? And again, we'll make one more. So this player. Okay. So that's one condition. And what can happen is there's going to be several conditions here for the situation. So for example, does the player have line of sight, or the enemy have line of sight for the player? If it's true, then let's move seek. Okay. What about if the player is within enemy radius? Well, then move seek, right? What about if the player doesn't have line of sight? Well, maybe then I'm just going to patrol, you know, and I don't have that as an action, but I should probably have that as an action here. So patrol. So move, patrol. If I don't have that, and that will also include some kind of animations for patrol. Okay. So move has has line of sight. Players then. What about if the player's health is less than 50? These are all considerations that we talked about in today's lecture. If the player's health is less than 50%, well then you know what? Let's do some close combat stuff. What about if the enemy's health is less than 50%? Well, that means let's get out of here. Let's flee. Okay, and so on. And what about if an obstacle is in the way? Well, then let's pathfind or do some obstacle avoidance to steer around the obstacle. And there's different options for you to do that. Okay. So that can be for the close combat enemy. There could be another enemy though. I'm just going to copy this enemy. So let's suppose that I want to copy this enemy around. So this one. And we're going to copy paste. Move this guy over here. Let's suppose there's another enemy over here. And that enemy over here is a kind of a ranged enemy. And again, just for completeness, this ranged enemy has a little tail we want to get rid of. So I'm just going to get rid of it just so that way we don't see it anymore. There we are. No more tail. It's got a bit of a divot now. And yeah, so what we want to do is kind of zoom out again. And so, yeah, so this enemy here also has line of sight, let's say. So maybe he's going to try and get line of sight to the player. So you can always draw invisible line of sight sight lines, to the player from each of the enemies. And here, as an example, there is no, there's line of sight. There's line of sight from both. Both are going to try and do different things to get to the player. One is going to try and approach the player. The other one, though, this enemy, which can be representative of the ranged enemy, maybe he's going to keep the player at a distance, right? So it wants to keep the player over here, right? It wants the player far away so it can continue to fire its ranged projectiles at it, right? That's what it wants to do. So that's one thing that it could do. And you could also have, sometimes what the enemy will do is want to go into cover. So let's say, for example, the enemy would also want to know kind of the closest cover, right? So maybe it's going to know about, it's going to know about each of the obstacles. Maybe I need to know about this obstacle. I need to know, maybe I have a list of obstacles. I need to find the distance between each of the obstacles to know which one is the closest one. Okay? So some kind of list of obstacles. And then maybe each obstacle is going to have some waypoints, right? So here's a waypoint, another waypoint. So each obstacle is not going to be just a simple block. Maybe it's going to have some waypoints here to help the enemy. And it can say, well, I got line of sight. I got line of sight. I've got line of sight. Wait, I don't have line of sight from this one. So when the enemy is hit, I can move to one of the waypoints around the obstacle that does not have line of sight from the player currently. So what I can do is I can say I want to move here, right? Behind this obstacle here, right? And then maybe what I want to do is when I'm done after a certain interval, I want to move back to one of these waypoints, a random waypoint that does have line of sight, okay? And you can update the line of sight every frame, as an example. It's not going to stop the player from getting line of sight on the enemy. It just means that after an interval or so, the enemy is going to move to some other place, whether it's here, here, or here, that where the enemy has line of sight with the player. Okay. And let's just, yeah. I'm going to leave these little waypoints here. Okay. Pathfinding could be also something you can do. You can use steering behaviors or pathfinding to find the player. But more or less from this one, if the ranged combat has a bunch of other considerations, does he has line of sight? How about the player? Is the player within the enemy radius? Is the player too far? Is the player too close? Well, guess what? Maybe they're going to practice some separation or cohesion from our steering behavior classes that we did. Maybe they want to move behind cover. What does that mean to move behind cover? Maybe I want to pathfind if I want to, get out of cover. as an example. Maybe I've wanted, what does moving out of cover look like, all right? And how do I fire a projectile at the player? Maybe I'm going to use object pooling for this. I'm going to fire a bunch of projectiles at the player from a pool of objects, right? So these considerations are things you should think about when it comes to making your assignment 3. Okay? Any questions around the stuff that I've been discussing today? I want to make sure that you guys are clear on the stuff that's due. Now this is all due next week by April 4th. That's a Saturday. So if you haven't started yet, you need to get going on this because it's something that you need to get moving. It's, again, this is your final assignment, which is going to be due next week on Saturday at midnight. Questions? Okay, so we're going to end it there. I'm going to stop recording YouTube, and I'll see you guys next week. I'm going to see some of you, some people on Monday, but for the most part, I'm going to see everybody on Thursday, and then we'll assess how everyone's doing by then. But remember, all this stuff, the things I did today, are things to help you. This template 9.1 and the GitHub repo I'm going to give you today is going to help you put things together for your assignment number 3. Guys, otherwise, thank you so much, and I will see you next week. I'm going to stop recording on YouTube at this point, right? So I'm going to end my stream here.